wanted to kind of get this thing rolling. I know some people are going to continue to log in as we go. So I'm kind of stalling a little bit, but we want to get started because we want to honor everybody's time. EPL has been doing business with us for quite some time. They're not only doing dietary fiber, they're also involved in crude fiber, detergent fiber analysis, fat extraction, hydrolysis for total fat extraction as well, and then of course dietary fiber. So they're very familiar with us as a company and our instruments, and they've got some history that they can talk about of that, and that's really the purpose. We're going to, like I say, keep it somewhat conversational with some questions, and then we'll just see where it delves into as we continue. So we want to be pretty open, recognizing as well that EPL is a commercial laboratory, so they're not going to share proprietary information and things like that. But anything that they can share, they're certainly going to share candidly with you. So with that, I'm going to turn it over to Nick, and he's going to introduce our two representatives at EPL. So Nick, why don't you take it away?
All right, Chris, thanks. As Chris said, we've got two folks from EPL who are longtime users of ANCOM technology products, pretty much all of our products. The first one is Brenda Dickey, and she's the lab analyst. She's in charge of the dietary fiber section over there at EPL. And she is also the author of this poster, which was presented at AACC. I'm sorry, AACC, and
this was in 2014.
2014. So this is a lot of good information here. If you want, we can send this to you after the fact. We also have.
We're assuming, Brenda, that you'll let us do that.
Right. Yeah, hopefully, right? All right. We also have Christina Johnson, who is a principal investigator over there.
Yeah, sure.
And
thank you, Brenda.
EPL. So between the two of them, we've asked them to be very candid and not to pull any punches, and just be very truthful with their experience with our products and with us. So we don't want you to think that we've selected these people just because they're going to give us a good review. We want them to be completely honest. So ladies, if you would say hi and introduce yourself. Or just say hi, I guess. I already introduced you.
Hi, I'm Christina Johnson. As you can tell, I'm a study director, principal investigator here. I work mainly in our nutrient comp, or for our nutrient comp studies, which.
Oh, we lost you.
Basically, we follow anti-nutritional parameters.
Okay.
Hi, I'm Brenda Dickey, and I'm a lab analyst with EPL. I am a lab analyst that primarily works with proximate methods. So hopefully I'll be able to answer some questions and be helpful in this presentation today.
Outstanding. And so with that, we'll start with, we've actually put the questions up on the screen. So Nick, why don't you go ahead and take that?
All right. So Brenda or Christina, why don't you tell us a little bit about EPL itself and what you guys do there and how you connected with ANCOM technology, maybe a little bit about how long you've been using our products.
Okay. Well, we actually started using them on over 15 years ago because actually one of our large seed companies, one of the large seed companies actually suggested using ANCOM, and they were, for us it really helped increase productivity. Some of the AOAC methods that we were using were very labor intensive, very time consuming. So it was a real blessing to us to find technology associated with this. And so yes, we've been with them for 15 years, and we have been very, very happy.
Okay. And you say that started because of a seed company that you were working with gave a recommendation. So obviously they were familiar with us, whether internally or through some other work. Outstanding. And give us a little bit of background about EPL. Help us to understand who you are and the kind of things that you do there at EPL.
Okay. We are almost to 30 years we've been around, and we started back in the days of, I believe it was pesticide registrations, and since then we have evolved. I believe it was in the early 2000s that we started doing this nutrient comp work, and it became a large portion of our business. We, like I said, we do proximate testing, vitamins, mycotoxins, pesticides, anti-nutrients, all sorts of things. We have many methods that we do for a wide variety of matrices as well. We have done corn, sorghum, soy. Those are some of our big ones. Canola, and I mean we've done diets. We are even in the pet food testing business. So it has been. It's been a great thing for us. It's been a great niche, but we also have an ag chem division where we do many ILV type of studies, magnitude of residue studies, and we also have a molecular division as well.
Okay, so you're pretty broad-based, and then I'm making some assumptions here, but you probably do business with the customers you have probably are from all around the United States. Do you get any international business as well?
We do. We have actually done business with some companies, yes, overseas.
Outstanding. So pretty broad-based, United States and international.
Yes,
Okay.
and we like to tout that we are pretty much ag exclusive. We don't have an ag division. We are ag.
Oh, gotcha.
So
okay.
we are
So no.
very much in the agriculture.
Okay. When you say that, I want to make sure I don't misunderstand. Are you saying when you say ag, you're not on the human food side, or it's just agricultural-based product regardless of what industry?
Yeah, mainly agricultural-based products.
Gotcha. Okay.
Regardless of industry.
Okay, outstanding. All right. One of the things, obviously, the emphasis that we have here now is dietary fiber. Obviously, people may later have questions for you relative to the other products, but you mentioned in your discussion a little bit about the background, how you got to know us, that automation was kind of an issue because the labor-intensive methods that you were doing, and so you've been moving to automate a number of. Let's talk specifically about the challenges you faced when you were doing dietary fiber conventionally, if you will, glassware, and then what was it that put you over the top to decide to move to the ANCOM system? I mean, automation is obviously the key, but any other elements that were part of your decision process as you were looking to go from conventional to automated in ANCOM?
Prior to 2012, we were doing dietary fiber, the conventional method. We were having some struggles in many different areas. First of all, we didn't have the space. We didn't have the hood space. It was labor intensive. We had some problems with precision, with accuracy. That's just to name a few. So we had worked with that for quite some time, and then we had already done business with ANCOM for quite some time, and we had already many different instruments, and we were very happy with what we had. So whenever the dietary fiber instruments, the automated instruments were introduced, we looked into it right off the bat, and we actually jumped at that opportunity. We, I believe in 2012, early 2012, maybe I think it was around April, we ended up purchasing 2 of the automated instruments at that time, and we switched over from conventional to the automated method.
Outstanding. Yeah, and I do remember that because for those that are listening, we actually started delivering the automated system in 2012. In January of 2012 was when we first made it available, and it was made only available to the United States because we wanted to be able to make sure we could respond to any surprises based on different laboratory environments and things like that. And so EPL was one of the very early adapters in it. And we could talk a little bit more about their experience in the future. But Brenda, one of the things you mentioned that I think almost everybody will recognize is you're talking about precision and things like that. And that seems to be the most common issue we hear from labs all around the world, for that matter, because of all the variables that a technician can introduce. We see most labs have a standard deviation that in most methods wouldn't consider it acceptable. In other words, whereas many labs say standard deviation, or RSDs, but standard deviation in this case can't exceed a 0.5, and yet we're seeing people accepting, 2.7. I saw one that was even 3 point something for a standard deviation on triplicates. And so it's a big issue in the dietary fiber, both inter and intra lab. So yeah, what you're talking about is not unique to you guys, obviously.
Right. And what you just said, Chris, is absolutely the truth. I have, and we can talk about this in a little while if you'd like me to elaborate, but I do have, we did some comparisons for the conventional method versus the automated method, and for 3 separate matrices. We do more than that, but I grabbed 3 of them, and we have the comparisons for those. So that's something that if you're interested in, we can elaborate on.
Yeah, that'd be great. Actually, that kind of goes a little bit into this next question. Nick, why don't you take that?
All right, so it sounds like you've already kind of answered the first part. You've been using the TDS system since 2012, and you've been using ANCOM products since pretty much 2000, and you have, I know you guys have many copies of every instrument we make. You got 2 dietary fibers, 4 or 5 fats, 4 or 5 crude and detergent fibers. So you've got, I think you got every product we make. So let's speak a little bit about your experience and maybe a little bit of that technical data about, what has the instrument done for you as far, and what's your experience been with that, maybe from precision and maybe cost and time?
And actually, I'll elaborate one more element of that because I'd like you to be able to get in some of the validation work that you're able to share in that. But also, you had one of the early instruments, and we did make some modifications based on experiences at labs like yours. So, a little bit about your experience of if you will, whether they're growing pains or just how quickly things were corrected where we had issues.
Very much so. We did have just some minor issues on occasion, and once we reached out to ANCOM, and most of the time it's something that we could do over the telephone and troubleshoot or fix something on our own. But I'm so pleased with not only do you walk us through that and take the time to teach us that, not only by the telephone, but you have been out here to do upgrades or to make some changes and an update because again, we have one of the, I actually think we have the third and the fourth instrument, or maybe the 4th and the 5th, something like that. Probably. So we do have an early on, and anything that has been updated since then, ANCOM has been great about coming out to the Midwest and upgrading our instruments for us as well. So we've had we have a great rapport with ANCOM, and I'll just leave it right there.
Be happier.
Right, exactly.
Well, and we'll talk a little bit about, you started to share a little bit about the matrices you grabbed for your testing. Talk a little bit about that experience because,
Okay.
Go ahead. Yeah, you can go ahead.
Are you with us, Chris?
Yeah, I was.
Okay.
I cut myself off, but go ahead.
The 3 matrices that I have in front of me, maize grain, canola seed, and cottonseed. And when we looked at the comparisons from the conventional method versus the automated, it looks like prior to having the automated, we had, and I just grabbed a couple of them to take a look at here, on one particular study that we did for some comparisons, we had a standard deviation of 1.70. And again, this is the conventional method for maize grain, and another standard deviation at 1.71 on maize grain. On cottonseed, we had 2.01, and let me think, I have one more. see, where's that? Oh, cottonseed. My apologies. I think I just have the cottonseed and the maize grain in front of me right now. When we look at the automated, we have a standard deviation on the maize grain of 0.531, and we have on the canola seed, we have a standard deviation of 0.766 on that. So we do have a standard deviation on our cottonseed at 2.71. I do want to point out, though, that this was early on when we first had the instruments and we were working on validations for it. And when we had the conventional method, we also had a higher standard deviation as well. I think it's because we have very few data points on that to really work with. So we just haven't analyzed a lot of cottonseed. So that may be something that we would see differently if we were to do that again.
Yeah, because I would say that's again, to me, that'd be a very, obviously to you as well, a high standard deviation. I might try, I will try to pull up a chart here. We've done a lot of work with a number of samples, and I think our highest standard deviation is a 0.86, I believe. And so, yeah, we're normally, in most cases, I think we're below 0.5. So, yeah, but that's good to hear, again, real world stuff other than what we're doing here. So now that's excellent. What about...
Right. And the other two matrices kind of, they back up, they kind of speak for themselves with the standard deviations at being low like that. So I think that, if we were to revisit the cottonseed, we could possibly see a big difference.
Right.
And one thing that I do want to point out is that we actually have done, we've used ANCOM on many different matrices. That's what's great for us is it is very functional for many matrices, and we do see that. We have a very long list of ones that we have done, and we trust the ANCOM technologies for all matrices.
Right. Now, from a standpoint of comparison as well, are there any samples that you could not do conventionally that you have been able to do now with the dietary? I mean, I obviously have some in mind right now, but I'm curious about your experience. And I mean, this is usually related to filtration, because lots of times there's certain, and I shouldn't say lots, there's a number of samples that in the conventional method they cannot filter, whereas we can. So I'm just curious if you've had that experience.
Well, the reason, no, but the reason why is because prior to us going automated, we only did those 3 matrices for conventional method. It wasn't until we received the automated that we started doing a lot more of the matrices. For instance, I've done sorghum, soy meal, soy seed, cottonseed meal. We've done many different other matrices using the automated system since prior to 2012. So the only reason we really didn't see that is because we hadn't branched out.
Gotcha.
And
yeah, so I mean, I guess the good news in that it's allowed you to broaden your sample throughput, because there's some samples that you just didn't take time to do, but now you can. So that's good to hear.
Right.
Here's a question.
Exactly.
Now, here's a question for you. Would you want to go back to the conventional method and do some of these other matrices and for comparison?
Never. No.
How about
no?
how about filtration in the conventional method versus this? Do you have, maybe you don't have it documented, but differences in, I mean, one of the things that we boast is most samples can be filtered in less than 5 minutes compared to sometimes 15, 20, or 2 minutes, or 2 hours, excuse me, for the conventional. Is that your experience?
Well, I as the analyst who did the conventional method, I can tell you that filtering on the second day was an all-day, 8-hour day. It was nonstop 8 hours of filtering for 8 samples.
Wow.
In the QC and a blank with the replicates. It was an all-day filtering process. one person was in charge of doing the filtering.
Wow.
Yeah, that's a lot.
And what about, I mean, there's going to be a relationship obviously to the filtering because of time, but certainly removing all the manual steps. Do you have an idea? Have you calculated, and again, maybe you can only give us as percentage, can you give us an idea of the savings you've had in either cost per assay or overall?
I can't really give you a percentage, but I want to say that prior to the conventional method was a 3-day method. On the first day, it was the digestion period and the precipitation where it would sit overnight, and then the second day would be a filtering, and then you would have a second analyst coming in doing that part, while the first analyst would start over with the next, with the beginning, with the first process. In total, it was a 3-day method previously. So versus the automated, you have one analyst who can handle everything on their own. They can do it takes 2 days. You've taken 1 day out of the equation. So you're down to 2 days with the automated, and you're down to one analyst being able to do the entire analyses for that. So I don't have the exact percentage, but I can tell you that you're saving, whereas we were using the 3 analysts for 3 days, because that's what it required, and it was an all day. It was an all day on the first day and all day on the second day. And when I say all day, I'm thinking in terms of an 8-hour work day.
Right.
And then you would have an analyst come in on the third day that would dry the samples, ash the samples, and then run protein analysis for those. I'm sorry about that.
Right.
So that's where I can see the savings in the labor.
Gotcha. Have you done any, and again, this doesn't mean you certainly had to, but have you ever done any runs that you started like at the end of the day and just let it run, the machine run it overnight, and then you finish it off in the morning, or have you not done any of that?
We haven't done that, but what I can tell you we have had to meet some pretty tight deadlines, so we have ran back-to-back. We have ran the instruments for 2 8-hour shifts and ran a second shift.
Oh, okay.
So we have done 16 hours.
Gotcha.
So
you're doing, on times like that, you've done the concurrent runs where as soon as the enzyme digestions are completed and the first sample's down in precipitation, then you move to put a second set of samples up on top to start that process. So you take advantage of that, it sounds like.
oh yes, we have ran, we call them subsets. We have ran at full maximum 6 subsets, which again would be a 16, it'd be about a 16-hour process, or a shift, I want to say, 8-hour shift and another 8-hour shift. But we run ours concurrently, yeah.
Okay.
Yes.
Okay. And just for the benefit of those that are listening in here, because I want to make sure we don't mislead in any way. The protein, the Keldol and the ashing steps that are required in the conventional method are still required in the automated method. We don't automate that. We automate the entire process leading up to that. So basically, it's everything you do in the glassware our system does in an automated fashion. But just like with the conventional glassware method, then you do take the samples and go to a protein calculation and an ash calculation. So, that just so everybody gets a big picture on that. Maybe this would be a good time just to open it up and see if anybody has any particular questions. We tried to hit on as many as possible that we could think of, but maybe there's some specific questions out there. So if you have your mic muted and you want to go ahead and speak up, you can. We'll try to make it so we're not talking over each other. Or you can go to the chat box and just type in a message there. So I want to give you some opportunities to do that. So any questions out there?
Are they muted?
Well, they have to unmute themselves.
Oh, I see. Okay. So
we'll give you a chance. We'll give you a chance to, we don't want to just have necessarily quiet space there. Sometimes that's a killer for everybody, but we do want, if you want to type in a question, I just want you to be able to do that as well as speak out.
All right, feel free now. So Brenda, you guys are primarily doing the 99143, is that correct?
Right.
Okay. So you guys have not got into the codex methods or the older 985 method?
Could you repeat that?
So you guys have not gotten into the codex methods or the older 985 method. You've been sticking with the 991.
Yes, yes. We actually have built our SOP around that.
Okay. Well, that one is the most popular method I think we find out there. But the instrument obviously is capable of these other methods if if need be.
And while we're just giving it again, we don't want to just take up people's time to take up people's time. We want to make sure we're answering questions that are out there. And by the way, one of the things that we're going to do, and I believe, let me go back on the slides. I'm going to go back and I'm going to show you the two slides for both Brenda and then Christina. Brenda might be your first point of contact because she works with the instrument. She's basically in charge of that process. So there you see her email. So for those of you who say, well, gee, I'd rather talk directly, unfiltered, if you will, to EPL, there's Brenda's email. And, Brenda, I don't want to inundate you, but hopefully you can see some email and answer any questions that people may rather ask, if you will, privately.
Sure, sure.
And then I'll show you Christina's as well. And all of you would have received the follow-up reminder from Nick. Please feel free to contact Nick with additional questions. And Brenda, I do need to confirm, we made an assumption, but we really didn't have a right to make that assumption. That poster, is that okay for us to give people copies of the PDF, or is that not okay?
Yes, that's just fine.
Okay, so that is public information, folks. So if anybody wants that, please let Nick know, and we can send you a copy of that. I think that's actually from a picture we took. I can't remember, Brenda, if you sent that to me separately, if we took a picture at AACC, I don't remember. But
Go ahead.
Hi, this is Sarah Bryson from Niagara Foods. We have some questions about the non-filtering steps, such as ashing and protein analysis.
okay.
How exactly do you do that? Do you cut the filter off, or how are you getting everything? And because we do combustion protein, so we're using an Elementar.
Brenda, you're using Caldol, correct?
Right.
Okay, let me address the Dumas method. We have a number of customers, and I'd have to be honest and say it's probably limited. I know of about 10 customers that are doing Dumas. There may be more, but I have personal knowledge of 10 that are doing Dumas, in particular Elementar and Lico instruments. Generally speaking, what they're doing is, and let's talk from a TDF standpoint, a total dietary fiber. In a total dietary fiber, everything is captured in what we call the bottom filter. And so they do pretty much what you just somewhat suggested. They cut the polymer. For those of you that are not familiar with the instrument, it uses what we call a dual chamber filter bag. It is a large polymer connected to a specific filter matrix for the filtration process. So the top, if you will, of the dual chamber acts as the beaker for either the digestions or the precipitation, and then it basically allows the instrument to separate the two portions of the bag, open it up to do the filtering when needed. So to your point and to your question, they cut off that bottom portion. It's before you dry it, you heat seal it just above the filter so that the sample doesn't come out during the drying phase. Then you cut that polymer off, and so all you have is the filter portion, which you basically are able to split open. And what they normally do is they will scrape it and brush that filter into an agate mortar pestle setup, in which they just make sure they mix the sample real well. If they're doing like a Lico Micro, where I think they use 100 milligrams, then they're drawing an aliquot of that for it. And I know of three, maybe four, three that I can think of off the top of my head that did all their validation based on LECO or Elementar microsystems. Does that answer your question?
Yeah, it does. Thank you.
Okay.
All right.
And by the way, we do have I believe we still have a video that kind of shows how that's done. And so if you also send Nick an email, we can send you a link to those videos as well.
There isn't, if you happen to have a Dumas system that's the macro style that can handle several grams, I know there's systems out there from Elementar that I think can hold even 5 grams. Some people are basically taking that filter, sealing it into 3 sections, cutting it, and basically throwing the whole filter into 3 crucibles, analyzing it basically 1/3, 1/3, 1/3, and adding the results. So depending on which system you have, we have a solution for
So macro,
yeah, micro or macro. We have a solution for that. And as far as ash goes, it basically just, we have a procedure where you just kind of roll up, fold up, and kind of ball up the bag and put it in your crucible and ash the whole thing. The bag itself has no ash, and you know, it disappears very nicely, and you know, you end up with a real accurate ash count. So that's real easy, not a problem at all.
I have one customer in Europe, in the UK, that actually introduced me to something that I was not familiar with, a microwave ashing system, which does the ashing in 30 minutes. That just kind of blew my mind. And in their case, they are again ashing an aliquot of that of the sample, if you will, that they scraped out with the diatomaceous earth. And so, you know, that's another option that people have used.
Maybe we should ask Brenda a little bit about how they do the Keldol and ash, see what they say.
Sounds good.
Brenda?
We do the ash. Hi. We actually, we just do a pre, what am I like?
Pre-ignition?
Thank you, yes. And then what we do is we just fold it, we take our weight of the bag, and then we take our replicate and we fold it in 3s, and then we seal the bag and we place it inside of the crucible, and then we put a lid on the top of it and put it in a muffled furnace at 600. So we ash for 3 hours. So we actually base ours off of the AOAC 923.03 method.
Right. And that, by the way, that's a good point you just brought up. Ashing, because when you're putting in the bag and everything like that, when you do it, ash it that way, it is important to have the lid in it. We have, unless you have we've actually got, what do we call those, Nick? It's like a tall form, glass crucible that we get that is nice because we can push the bag all the way down in there. The normal ceramic crucibles, the concern that we have without a lid is that as it heats, if it springs open, then you might be throwing ash around, and so that's why we recommend the lid, as Brenda just talked about, that they use. That eliminates that issue.
All right, and for
so what size crucibles are you talking about using when you ash a whole bag?
I think it's 50. A 50, isn't it? I think it's a 50
people use what we call the tall form 50 milliliter. The nice thing is that they're tall and narrow, so they not only are the sides very straight, so the bag doesn't walk its way out, but they also sit next to each other real nice in the oven, so they don't take a lot of room. We also have some glass ones that we use. They're harder to come by, but they're
but those are the 50 milliliter.
Yeah, they're both 50, right? So 50 is the answer.
And Brenda, are you using you're using the standard, if you will, crucibles, and those are 50 milliliter?
Yeah, we are no longer using the ceramic crucibles.
Oh, okay.
We stopped using those maybe 2 years ago, I want to say. We are using the same crucibles that we used for our ashing method. The quartz fiber crucibles.
Okay.
And they come with the lids, and so we just place the lids on the top of those, and we've been successful with that.
Oh, you're talking about like the ones from CEM? They're the fiber?
Exactly.
Yeah.
Exactly.
Forget about that. People use those too, and they cool almost instantly, a couple 10, 20 seconds.
So we did that for 2 reasons. We did that for one, because of the cooling, because it takes a significant amount of time for the ceramic crucibles to cool. And secondly, the ceramic crucibles that we were using, we, from time to time, whenever would fold the bag, seal the bag, and place it inside the crucible, the crucible would crack or break.
Oh, wow.
So we looked into a different alternative, and that's just you know, that's just what the experience that we had, and it wasn't all the time, but it did happen.
Okay.
So you take your empty crucible weight, and then when that happens,
kind of wrecks things.
Yeah, it makes it hard.
That's a good point.
Right. So.
And then for Keldol, the only difference, and again, I know the question was Dumas, but just because there are probably people out there doing Keldol, the only difference with our method is that we'll slightly increase the amount of hydrochloric acid used in the block digester. I believe it's 27 milliliters versus 20 is what the standard is. And that's because that's when we, even though we're cutting off the bottom filter, there is diatomaceous earth and the filter material to deal with. So in those cases, we also, that's why we increase the amount of hydrochloric acid during the digestion. Any other questions?
Have we answered your questions?
Yep, that was it. Thanks.
Okay,
Thank you.
All right, we're going to, hopefully the recording worked. We will post this up on our website. Again, you've got Brenda's email right there. You've got Christina's email right there. And again, you've all got an invitation from Nick. So please feel free to communicate with us. Nick will obviously follow up with everybody just to make sure that there's no other questions. And we'll go from there. But thank you, everyone, for your attendance. We actually were able to do this in under an hour. And keep an eye out, because we are continuing to look for ways to add more webinars that can get into some of the different proximate chemistry and different things that we're involved in where we can hopefully be of assistance. So with that, Brenda and Christina, thank you very much for your willingness to participate in this. And thank you, everybody, for coming.
You're welcome.
All right. Yep.
Welcome.
Thank you very much. And yeah, well, this will be available online here probably by the end of the week.
Thank you, everyone.
Thank you. Bye.